Hello there. This is another lecture series. Um, Similar to what we've already looked at, this is attribute data models and queries based on the text that I have for you guys. So I just reworked that and I'm putting that out there for you for an additional theory that's going to help reinforce these introductory concepts of GIS and are going to be necessary for when you're taking your exam. Knowing this kind of information is really going to be extremely important. So, I'm going to do a short summary of what we've put together here from GIS Commons. I want you to read this by yourself, though, as well, so that you really get the full breadth of what we're talking about here. So attribute data model and queries, one is really kind of built from the other. The attribute data is an essential part when we're talking about GIS and data in particular and what that all means. So yeah, we could say GIS programs link attribute data and digital maps. And we know that there's the mapping component, that's the visual, that's your location, where things are in space, okay? And then the attributes are the those are the features, information about the features, right? So like we talked about, here's fire hydrant A, and it has three openings on it, and it's red in color. Well, you could have a whole database of different fire hydrants for the city. That's all considered attribute data, okay? So let's see. Yeah, attribute data, it's descriptive, okay? So it describes things. And in particular, it can describe non-spatial features, okay? So like I was just saying, right? Red or how many flanges. I mean, it could be anything that you're thinking of, assets, whether it's specific assets in this case, maybe it's election data, demographics, yada, 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 right? It could be anything, okay? But it doesn't necessarily mean that these are spatial records, things that have some type of map component to them. They're just information about what you have on the map, okay? They could be spatial in regards to, they could be a coordinate or an address or something like that. So it's not that it's all or nothing here, but trying to separate where, the value of attributes are, and generally speaking, what we think of when we're talking about attributes, it's some kind of informational, information that we're putting out there. And that information gets broken down into, now as we try to dissect this, either quantitative, which would be numerical, okay? And so numerical could be spatial, it could be non-spatial, but quantitative means that we're talking about numbers, okay? Absolute manipulate mathematical, integers, okay? So whether it's some kind of statistic or it's some kind of even like an address, like just the numerical part of an address, that's a quantitative record, okay? A quantitative attribute. So quantitative, when I think of quantitative, I think of quantity. And so I could think of something as I'm counting it. There's really no gray area when it comes to quantitative data. Let's put it that way, okay? Now, the other side of this would be something known as qualitative data, okay? Your data could be qualitative. The attribute could be qualitative. Qualitative comes from quality. So quality, if you think of quality, you say, what's the quality of, that car? And you go, oh, it's really good, right? It had really good ratings. Chances are those are going to be some type of subjective, right? Some kind of judged or opinionated results that have placed it into a excellent, good, better, or good, medium, bad types of ratings, right? So think of the quality of something. That's a qualitative attribute. Different than quantitative, right? Quantitative you could count. qualitative, it may be something related to a number, but it's not the number in specific. So you could say, okay, so what was the rate? What was the how did that car how was it judged? Oh, it was excellent. Okay, that's qualitative. What was the car's rating? Was a 5 out of 5. That's quantitative, right? So just trying to be careful when you're making the distinction between the two things. I use those terms almost daily when I am just going about my day, talking about data. So this will come back to you on a regular basis, understanding the difference between quantitative and qualitative, and where do they fit in relation to your attribute data. And as you're making these kind of calls and manipulations that we're going to talk about here shortly. Yeah, so I have my little bullet points here. That's what these little notes are. I'm reading something here to help me, as I'm not just reading this stuff word for word. That would be kind of boring, right? But as we go through this, I want to talk about how data can be defined, right? And so it could be either absolute, where it can be measured. So like, for example, as we're breaking down this attribute data, it could have been a survey of, folks who they're going to vote for. And so that would be some type of absolute value that's being represented by the attribute data, or it could be created. And when we talk about created data, we refer to that as derived data. You derive something. Okay, so a derivative, right? A derivative means that a derived attribute means that not occurring naturally, they can be directly or cannot be directly gathered. Excuse me, result of statistical manipulation. So yeah, what that means is, essentially it's like you have data, say that's existing in your attribute database. Normally derived comes from an absolute. So when we talk about the derived data examples, generally speaking, those are some type of statistics. Okay, that's what I want you to remember: derived data, statistics. Okay, so you're running some type of further analysis, statistical analysis about whatever absolute data that was collected, right? So like a ratio analysis, how many of something versus how many of something in a sample versus how many of that same thing in a population. A proportion compares the value of one attribute to the total value. So the proportion of all African Americans to the total population, that's actually quite similar. Am I saying that I don't want to say that the wrong way. Total number of people with a particular region and divided by the region's area. Ratio and proportion are very similar. Let's see, but the calculated population density attributes is derived. I'm gonna let you guys go back and read this because I'm not gonna try to just read this stuff word for word. You do need to know the differences between these things, or at least know that they exist. I think the important part about what's gonna potentially come up on an exam for you guys would be, really understanding absolute versus derived. And so if I say something like a ratio is part of a absolute value collected, that's not really the right answer, right? The right answer would be no, that would be part of a derived statistics, derived attribute. So yeah, proportions as percentages, they're similar, but percentages multiply proportions by 100. So yeah, percentages are another part of that. All very similar, but reread these things to kind of reinforce what I'm talking about here. Now, let's discuss, let's see, did I miss anything here? No. So let's discuss databases, okay? Since we're talking about attributes. Attributes come from databases. Well, what are databases? Databases are like your collection of records. And so an Excel sheet where you have various things in there, right? Quantitative or qualitative or both. that is a database. Okay, so database management. And in the GIS world, when we talk about database management, we're talking about the data files. We refer to those as tables. So an attribute table. Okay, so breaking this down, your fields. Okay, fields are known. Those are the columns. Okay, so the fields are like, for example, the distinguishers of the different types of attributes that occur, right? So example like could be an address, the perimeter, I'm not sure what they have as APN, but land use, lot size, right? These are all very different distinguishing things about distinguishing attributes about a certain thing. And then and so each one of those is considered a field, okay? Column being in the vertical direction, right? These things are called fields, okay? Now, for the specific thing itself, I think we talked about this already, right? In the other lecture. For the specific thing itself, we would call that a record, okay? So the record, the individual feature itself, that's a record here, okay? So the rows then are your records, okay? So the whole thing is a table. The fields are the columns and the records are your rows. Yeah, important things to know. Now, as we go through a single record, let's see. Record is individual attribute. Let's see, single record in a row represents a database version of a single feature. Yes, so let's be specific about that. When we say single feature, say you have 25 of these fire hydrants, right, in one layer, and you're trying to call out, one specific fire hydrant. Well, that one specific fire hydrant is going to be that single record. And in terms of the table, how it's going to be represented is all of the attributes, okay, that are associated with that single record for that single fire hydrant. That's how it creates a row of things. It's not just a single cell. That's how it creates a row of different attributes, right? There we go. Okay. So I definitely want you guys to know about that, reinforcing these concepts here. Here's the example we just kind of talked about. And so let's see, new layers are mostly empty. It's interesting when you let's say create data from scratch, right? You want to create a new shapefile or a new layer of like a pond outline, or I don't know, some other kind of asset. Maybe it's a parking stripe, or it's whatever, right? Just a dot to represent a county. I don't know, whatever it is, right? So you can go about creating data from scratch by essentially going into GIS program and saying, okay, create a new file. Okay, cool. Create a new layer. And it's going to say, okay. And then it will come up and you can go in and you can go about it one of two ways. I generally go in and map or plot out what I'm trying to, visually put on the screen. And then I would go after that and add my attributes, secondhand. There's another way to go about it that would be kind of the reverse order that I'm going to talk about a little bit more in a second. But anyways, the point I'm trying to make with this is it's all fine and great to go in and plot all this stuff out. But what's going to happen is you're basically going to have a blank table with only the record of 1, 2, 3, 4, 5 of when the features were created. So at that point, a very common job is to start populating that attribute table. Start populating the attribute table. So I'm saying the user, you will have to go in. That could be a common job for you to go in and actually populate that attribute table. Okay, and so that could be done by hand. Hopefully you don't have too many records to do by hand, because that would be a very tedious type of job. Another way you can be done is through joining, or joining is the most common way. So taking an existing table, an existing database, and then essentially merging it in. So like gluing it into the gluing it to the GIS layer. And then boom, in GIS, you have what was initially independent over here. Now you've got it in the GIS as well. And it all relates to the same map, okay? The same features you just put on the map. So that's a little bit more complicated that I'll get into later on. But that's what we're talking about here with all this joining stuff, okay? Let's see. I do want to talk about the different file formats, just so that you guys know that they exist. You don't need to know these by heart, but I do want you to know the different types, because these will come up and you will be confronted with these various types, especially if you're creating data from scratch, right? So like a DBase database file. That's very common, like GIS version of a spreadsheet, okay, called a DBase database. Excel and Access, well, we all know those, right? So those are another file formats. ASCII, ASCII is what it's actually saying there. And, you know, that's the most universal language we have, because essentially what we're looking at is a text file with just very simple records of something. Those records are usually separated by a comma or a space. And yeah, those can be kind of tossed back and forth. Now, sometimes they're a little too simple, but I would say of all the file formats that are out there, just in my experience, the more I do this, the more I work in ASCIIs, because they are, again, the most universal, and it can be kind of loaded into something different than GIS, right? So it's like this kind of catch-all file type, right? So I want you to know those file formats. Let's see, what else are we going to talk about here? Okay, just some basics here in terms of attribute processing and editing. I want you to be aware of these things. We should be going through some of these processes in the lab. So you'll get familiar with these kind of common table editing practices and techniques, okay? Adding or deleting fields, or deleting individual records, okay? And then sorting various records, right? So these are all kind of specific to the software that you're working in, right? And different platforms, even in the same, like something by Esri as one platform, maybe the Pro versus online, could look totally different in the way you have to go about the same type of technique. So again, this is theory so that you understand what you're actually trying to do. Add, delete, sort, that kind of stuff, right? All possible, all very possible, again. So let's shift gears a little bit to talk about now what we're going to do with this attribute data. And so in this instance, what I'm referring to is query, querying the data, creating queries, Q-U-E-R-Y. Okay, so it's like a question is the way I like to think of it. Like, find these things, or where are these things located in relation to something else, or only show me, maybe not a question, but kind of a command. I guess that's more actually appropriate, a command. Show me only the records that are 25 and above, right? Or show me only the records that are in Sacramento, whatever, right? And then then GIS can go through and say, boom, show me those things. So also called filter, right? If you're familiar with Excel, and also ArcGIS Align calls this the filter process. So it's exactly what it is. It's all the same type of thing. Standard query language, SQL, and that's what's behind the scenes here. I'm not much of a coder myself, but I have a general sense of what these things mean. But yeah, essentially what you're doing is you're creating a command to tell the software to go out and find something and then display it, right? And so that's what a query is, okay? It's a selection process. You're selecting various records based on criteria. We talked about this previously, I'm pretty sure. But anyways, let me double check that we did. I think we did. Yes, we did do that already. Yeah. So when we talked about the set algebra thing, remember this, right? This is all querying stuff. Now this is the old ArcMap, interface, but again, it's the same idea, right? You're trying to filter out and select only something based on, or some things based on specific criteria. Okay, so like in this example here, you got to know these things: the and, the or the not. Right? These are these will have a very specific. You'll have a very specific outcome in your query based on what you're choosing here, or what combination that you choose here, right? So I'm not going to repeat myself in this instance. I know you guys already saw that video, which is important as well. Okay, so let's move on. And there's the query based on the attributes. That's one thing. The other types of queries are called spatial selections or spatial queries. Okay, so spatial queries, that would be, or spatial searches, that would be when you're looking for calling out features based on some kind of location, okay, information. So like for example, say you have, and this is when the map, this is again, spatial, this is when the map component actually really does matter. So say you have like a county boundary like this, right? And then you have various parcels of properties, whatever they are. And some of them are outside the boundary and some of them are within inside the boundary, right? Your task is to only work with the parcels that are within the county boundary, right? This kind of stuff is going to come up all the time. I tell you this with peace and love. This is very frequent types of things that you're going to deal with, right? How you filter and then only use data that you're wanting to that you need for accomplishing whatever tasks you're working on. So the example, like I said, okay, we found only the records that are within that county's boundary, and that's the only thing we're going to keep, right? So that's an example. This whole location thing, there's a billion, not a billion, but you get what I'm saying as the expression goes. There's a billion different types of location stuff. Could be within it, but also intersects the boundary. Could be outside of it. Could be within it, but has a buffer of 10 miles between each one or something like that, right? So because it's part of the map, you can now run these various types of questions related to location and nail down very specific queries in this case, right? Selections. So where all of this really starts to tie together is when you combine both things, right? So you combine the attribute query and the spatial query as two strong single queries at once, right? So I need to find all of the things within the county that all of the parcels located within the county that only have a good rating or something like that, right? And so the good rating part has nothing to do with location. That's a location, that's an attribute, non-spatial related attribute, right? A qualitative thing. They're all within the same table. What your job was right there was to then find something very specific in terms of what you're filtering, okay? So yeah, putting this together in a nutshell, that's what we're talking about here when we refer to querying, and it's extremely important. I'm telling you guys, these are foundations, right? Foundations of working in GIS. Okay, so let's see, what else were we going to work on here? Calculating attributes is another attribute table function. And what I'm talking about here, meaning that say you open up your data file, you can create new attributes based on existing ones. In particular, we're talking about quantitative values here. So say you wanted to, you have a whole list of records, a whole list of numerical records, and you wanted to create a new field, the same records, but divided by 2 or something like that, right? Or the same records squared. I don't know, whatever it is, right? You can run various types of mathematical operations, basically, and come up with, this specific, for whatever reason, but this very specific derived attributes. Now we're talking about, again, derived attributes in this case. So yeah, there's called a field calculator. And so that's where you would go in and you would basically say one minus the other. You could actually, if you have 2 different fields that are both numerical and that are, your absolute that you recorded, you could say, I want to subtract one from the other and give me that result, right? And so that might be an important query that you are tasked to figure out at one point. So yeah, calculating attributes is a possibility. The last thing I want to talk about when it's referring to this attribute tables, attribute models module is just something called geocoding. Okay, geocoding. Now, geocoding, when we geocode, what we're doing is, it's like I was saying earlier, you're creating, say, a file from scratch, and instead of, say, tracing, the location or drawing it or sketching, whatever it is, say you have the location information stored in an attribute. So like, for example, you have coordinate information stored in your attributes. So you can load those coordinates into GIS and say, plot these things for me. Create the map for me automatically based on these coordinate values, right? And so that's a form of geocoding, okay? The software looks at the coordinate values and then says, okay, here's a plot of those things, right? So, so that's one example. Let's see, another example could be what's called address matching, okay? And this is becoming more and more common because, like, in particular, GIS Pro is very good at understanding specific attributes. I think when they were writing it, they somehow put in criteria for addresses, again, based on some databases somewhere. But anyways, what you could do, say you don't have coordinates because maybe you're working with a real estate file or something like that, right? Where it's not, a GIS person or a geo person or a surveyor person that has coordinates that they're handing to you, very specific locations. They're giving you addresses and they go, well, here's the information, figure it out, right? So this is possible as well, called address matching, taking addresses and then plotting those on a map and creating a file that way, okay? Then saving the plot. So that would be a form of geocoding under the guise of address matching, okay? Let's see. And so, yeah, at the end of all that, ideally, because you would be doing specific analysis or passing this data on for some other type of archive, you would save your data and then potentially even export the data if that's what you're tasked to do, to send it somewhere else. So data export is extremely common task that you'll be working with at some point in your GIS endeavors. Okay, I'm glad we got to run that down. So thanks for watching. This attribute stuff is, like I said, foundation, so we have to make sure we cover a lot of bases here, and this information will definitely be part of your exam. Okay, so make sure you go back, reread this document, and understand what we're talking about. That's going to be an important part of this. Thanks so much. See you later. Bye for now.